In this example, we're going to use the graph of a function to identify various properties about that function. In particular, we're going to look at where it's positive or negative, where it's increasing, and also where it's decreasing, and then where it's concave up and concave down. The last thing we'll do is identify any local maximum or minimum values and state where they occur. So the first one we have here is that we're asked to state the intervals where h is positive. And so as we look at the graph, for the function to be positive, that simply means that its output values are positive. So what we're going to look at is we can see on this graph that at -2, the function's value is 0. And then everywhere to the right of -2, we can see that those function values are positive. And as we look at that, we can see that the graph of y equals h of x is above that x-axis. So that's our key way of identifying that the function is positive there. So as we state that, we'll just use an interval, and so it'll be from -2 to infinity. Note that we're not going to include -2 because the function value is 0 there. In this next one, we're looking at where the function is negative, and so we can see that the function is below that x-axis for all values that are less than -2. So when we state those values of x as an interval, we'll write from -infinity up to -2, and again we'll use an open bracket on -2. The next one we're looking at identifying where this function is increasing. And so in order for a function to be increasing, when we're looking at the graph, we're looking at, as we read the graph from left to right, we're looking to see that those y values go up as we read left to right. So I'll highlight along the graph here. So I'll start in this lower corner, and then as I come up, I can see that when I get to this point 2, 8, the function stops increasing. And then if I come over here and I start where x is 6, at this point 6, 4, and then keep going up, I can see that it increases again. So we're going to state the intervals where h is increasing, and so one of the things we want to know is that we're always going to identify the x values for which this function is increasing. So when we state those intervals, what we're looking at here is that we're looking at, so it's increasing everywhere to the left, and then at 2 it stops increasing. So we're going to have our first interval be from -infinity to +2. And then it's also increasing. See, we see that this starts at the x value of 6. It starts to increase, and then onward. We see that arrow on the end of the graph showing that the function continues in this way. So it's also increasing from 6 to infinity. In this next example, we're going to look at where the function is decreasing. And so if we come along the graph here, we can see that from 2, an x value of 2, to that x value of 6 along that graph, the function moves down as we read it left to right. So the interval where that function is decreasing is then the interval from 2 to 6. Keep in mind that we're stating intervals. We can see that this open bracket 2, 6 with another open bracket, that could be mistaken for a point, but we need to keep in mind that in the context here, we're stating an interval. So we know that this is the interval from 2 to 6, representing all values of x between 2 and 6. Okay. So the last two things that we're going to look at involve concavity. And so in this course, we're not looking at concavity very in depth. We're really just looking to see graphically how the function curves. So the best way that I use for concave up is that, I'll draw this cheesy smiley face, but whenever we have any part of the graph curving upward, like we see here, that's going to represent where the function is concave up. And then for concave down, anytime, I'll draw a sad face there, anytime the graph looks like any part of that curve that I've drawn in that frowny face, we're identifying that the function would be concave down there. Now for this course, we don't have a means of identifying exactly where the concavity will change, so we'll use our best estimate when we look at this graph. So if we come over to the graph, I can see that there's this local maximum point at 2, 8. And around there, the function's curving down. I can see that there. So I can identify that it's concave down around that part. Okay, and I changed that color to match the black color we've written with concave down here. So we see that piece is concave down. And then as we come over here, we can see, so I see this local minimum point at 6,4. And I can see that around there it's curving upward and then to the sides of it too. So I'll add that in. That's curving upward. So I've got the basic areas where it's concave down and concave up. And so from here I'll estimate where that switches. The other thing that we want to note is that concavity and increase and decrease are two independent concepts. And they're not synonymous with each other. So we can see that on this piece of concave down, part of it's increasing and part of it's decreasing. And so it's important to note that we have to determine where something's concave up or concave down completely separately than how we determine it's increasing or decreasing. Okay, so we've got enough sketch there. Let's state some intervals. So if we look at this piece for concave up, I'm going to estimate that concavity changes around an x value of 4. So I'm looking at that point 4, 6 on the graph, and I'm estimating that it changes there. In calculus, you'd learn that that point would be the inflection point on the graph. So all we're doing here is estimating that it's changed somewhere between where I see very clearly it's concave down and very clearly that it's concave up. So for that interval of stating where this function is concave up, I'll use the interval 4, infinity, and again an open bracket. And then for concave down, I'll use an interval with negative infinity up to 4. Okay, and the last thing, so we have our intervals of concavity. The last thing we're going to do is state any local maximum or minimum values and where they occur. And as you'll note, I've identified these a local maximum point and a local minimum point. What we're being asked to do here is state local minimum and maximum values, and that's a very key distinction. These are going to be function values, which means that they're going to be y values on our graph. And so anytime we see we're talking about a function value, we're talking about an output. In this case, that would be y. And this word where, that's always referring to an input value. So that'll be our x value. So when we state our local maximum value, let's do that one first. I can see, so this needs to be a y value that's higher than all of the y values that surround it. So I can see at this point 2, 8. There's that little peak on my graph. And so the local maximum value there will be 8, and that's occurring at 2. So there is a local maximum value of 8. And we would say, we could just stay at 2. I'm going to do this as two separate sentences so we get very clear that the maximum value, the local maximum value is 8, and it occurs at 2. Okay, and then for the local minimum value, I'll see that over here. And so I see this point 6, 4, and I see that at that point the y values are lower than all of the y values around the function there. And so our local minimum value will be 4, and that's going to occur at 6. So we can then state there is a local minimum value of 4. And we could just say of 4 at 6, but I'll do this as two separate sentences. So it occurs at 6.